Look up on a dark night and you might spot Andromeda. It's a faint smudge about 2.5 million light-years away. For nearly a century, astronomers have told a story with a fixed ending. Andromeda has been falling toward us since our ancestors first walked the Earth. Over 100 years ago, astronomers measured the galaxy's blue shift. The light from its stars is squeezed toward shorter wavelengths, meaning the distance between us is shrinking. The best estimate puts Andromeda's approach at about 110 kilometers every single second. To know if two galaxies will actually hit, you need to measure their sideways motion. For decades, that motion was too small to track. In 2012, 8 years of patient observation by the Hubble Space Telescope finally pinned it down. The conclusion landed hard. The galaxies were locked on a collision course. That data solidified into common knowledge. The survivors of this galactic crash would merge into a single, swollen elliptical galaxy named Milkomeda. It became a scientific prophecy, appearing in museum posters and documentaries as the unquestioned fate of our night sky. In the middle of 2025, a quiet paper in Nature Astronomy asked an inconvenient question. What if the ending was never settled at all? The definitive end of our galaxy was suddenly downgraded. It shifted from a mathematical certainty to a cosmic coin flip. This chart shows the probability of a direct collision over the next 10 billion years. In the originally predicted 4 to 5 billion year window, the chance of a direct merger drops to just 2%. Over the entire 10 billion year stretch, the odds hover around 50%. This collapse in certainty suggests that our earlier confidence was a byproduct of what we couldn't yet see. As our instruments improved, the single clear path began to blur. The European Space Agency's Gaia mission spent a decade tracking nearly 2 billion stars in our galaxy and its neighbors. It measured their positions and motions with a precision that far surpassed previous eras of observation. When researchers combined Gaia's massive dataset with Hubble's older observations, they finally had a clean picture of Andromeda's motion. A team led by Till Sawala took these new numbers and ran 100,000 distinct simulations of our local group's future. They varied 22 different parameters in each run. They adjusted positions, velocities, and masses of the major galaxies, staying within the bounds of what the new data allowed. They weren't looking for a single timeline. They mapped the shape of our ignorance. Usually, we expect more data to narrow possibilities. Here, precision revealed the trembling in the numbers. It exposed how much room the data leaves for other answers. In highly complex systems, better measurements force us to trade a guaranteed fixed timeline for a distribution curve of possibilities. The reason the future is so uncertain lies in the small print. If we widen our view, we see the Milky Way and Andromeda do not exist in an isolated vacuum. They drift inside a small crowd of dwarf galaxies and middling spirals known as the local group. Two of these neighbors matter immensely. The first is the Triangulum galaxy, or M33. It adds mass to Andromeda's side of the scale, tugging the two giant galaxies closer together and supporting the old collision theory. But the ultimate disruptor is the Large Magellanic Cloud, a bright satellite galaxy orbiting our own. By galactic standards, it is tiny, maybe 1% of the Milky Way's mass, but it refuses to cooperate. The LMC's orbit runs almost perpendicular to the plane between us and Andromeda. As it sweeps past, its gravity gives our galaxy a sideways nudge. Over hundreds of millions of years, that pull slowly bends the Milky Way's trajectory, pulling it off its rails. Gravity ignores narrative importance. In a system this finely balanced, a microscopic nudge from a minor player is all it takes to turn a fatal collision into a near miss. Astronomers generally agree there is no reason to lose sleep over our changing cosmic fate. Long before Andromeda arrives, the Sun will seal our planetary fate. In about 1 billion years, our star will swell as it approaches its red giant phase. It will heat up enough to boil Earth's oceans and scorch the planet entirely. Earth won't be here to watch the end. Even in simulations where the galaxies do merge, individual stars almost never touch. Space is mostly empty. If the Sun were a ping-pong ball, the next nearest star would be a pea over 1,000 kilometers away. It is a slow choreography, not a violent crash. The discovery measures our intellectual capacity to understand our place in a larger, indifferent cosmic dance. The 2012 prediction relied on the best evidence available at the time. It simplified a universe that turns out to be much busier than we imagined. Science is at its best when it honestly acknowledges the size of its own shadows, rather than delivering unyielding dates. We now sit comfortably with an open question. We are observing a cosmic coin flip that we can study and refine, even if we cannot control it. Every new instrument we point at the stars widens what we can see and deepens how much we know we do not yet understand.